Assalamualaikum and good day everyone. I hope you all doing well. Okay, for now we are going to continue with chapter 5, which is filter. This is the first exercise for chapter 5. Okay, so basically when you are given a transfer function, you want to you want to plot the transfer function, which is we're going to plot the magnitude and also phase of the transfer function. We have to first change it to a standard form. Okay, so a standard form, as we all know, there is three types of term, which is constant term, pole zero at the origin, and simple pole zero. So you have to be familiarized with the term that is actually exists in order for you to have the idea on how you want to reorganize the equation that to a standard form representation. Okay, so basically what I do here is to readjust the equation to represent the standard form. Alright, so actually we have finished, and you can see here is that this is the standard form that we have managed to obtain. And as you can see here, all of the form represent the three terms that we have learned before. Okay, so if you didn't really probably see it by now, let me label it for you. Alright, so after you have finished that, you don't really have to label that in your during your examination or test. Okay, it's just a good practice during exercise. Okay, so after that, after the first step, then the second one is that to change all of the term into a decibel. Okay. And also, once you have changed it into a decibel, the third step is for you to change it into a phase form. And now come to the final step in answering this type of question is to plot the ball plot in the semi-log graph paper. Alright, so basically once you have the semi-log paper, the first thing usually we will start to plot the magnitude, okay? So usually before we start, we have to know the range that we want to plot, meaning how many range of the decibels that we are going to use, how many range of the frequency that we are going to use. So from the oh, here I think I should change it to the decibel representation. Let me change that for you here. Alright, so now as you can see, we actually have several terms. So okay, so actually we have the first term, the second term, the third term, and the fourth term. So basically you have to plot each of these terms, and then after you have plots all the terms, then you have to plot the final term, okay? The overall. And as for the phase, we have 3 plots, okay? Because the first term, which is the constant term, the representation of it in phase in the phase plot is actually 0. Okay, so now referring back to the term, to the semi-log paper, as you can see, you have to observe the value. So we know that we're not really going to use such a high value, or probably any value that need us to adjust the semi-log paper. It's just that we are going to use a basic value, which is the decibels from 20. We can start with 20, moving up to 40, 60, 80, and so on. And as for the the exponential, which is the cycle, I can see the value that we have is 1, meaning the minimum value that we should have in the paper is 0.1. Okay, because we need that in during the plotting of the simple pole 0. Okay, alright, so yes, label it like this. Yeah, actually I erase it because I think it's better for you to label it down, I will like below the graph paper, so that it will not really disturb the whole plotting, but it's up to you. Okay. Alright, so I have labeled this semi-log paper. So now I'm going to plot the first term that we have, which is 20 log 10. So now I am referring to the notes. Okay, so for constant term, we have 20 log k. The graph, the plot should look like the first one, which is a straight line from the value of 20 log k. So for our term, the k, for our k we have 10, so that 20 log 10 is equal to 20. So that means I'm going to plot a straight line from 20 decibels. Alright, so once you have plotted, I would like to remind all of you to label every plot that you have, because sometimes we have an overlap plot. Okay, yes, you have to label it. Okay, so now we are going to move on to our second term that we have 20 log j omega, because the term look the same. So we will plot the exact same plot. Okay. Alright, because the value is positive, so we'll plot a straight line going up from negative 20, which is going up a decade with a factor of 10 of 0.1, which is 1, and going up some more with the incremental of exponential. So we will have from negative 20, 0 to 20 decibels, and going up straight for simple pole 0 at the origin. Alright, continuing to the third and the fourth term, it is actually both of the term are in the same, I can say, same format. And not to forget, both of the term are in negative value, which means it will go the other way, or the mirror image of the original signal. So yeah, for simple pole 0, we will have to consider the Z1 value in order for us to plot. Alright, so here I will write here the value, because the Z1 value is 2, which means we will start plotting from 0.2, 2, and also for 20. And for 10, we will plot from 0.1, 10 and I'm sorry, it is actually I have to start plotting from 1, 10 and also 100. Correction, okay? Okay, so to start the plot, I will first label Z1, which is 2. The value is 2. And then I will label the factor of 10 of 2, which is 20. And then after that, we will start plotting the line. Okay, so we'll go actually from 0.2 to 2 and also to 20. But then the decrement will start from 2. Alright, so of course, do not forget to label. As I said, you have to label every plot that you have done, okay? Alright, so for now, let's begin plotting the final term of the magnitude. So we know the value is Z1, the value of Z1 is 10, which means we will start plotting from 1, and then 10, and then 100, with the decrement of 20 decibels. Alright, so after you have plotted all the 4 terms, you have to plot the total, the addition, I can say, that represent the transfer function, because currently we are asked to plot the transfer function, right, which is h omega. So after we have plotted all, you just have to do the addition of all the plotting in order for you to plot the final plot that represent the transfer function. So here I really advise my student to plot from separated, I can say, from cycle to cycle, okay? So for now, for the first cycle, we have 3 signal, which is 1 straight signal, 2 straight signal with 1 increment signal. So with that, we added the 2 signal. It will become, it will start at 0, okay? Because negative 20 and 20, the value is 0. So what left is the signal that is going up. And then for the second cycle, actually, I started to plot for the first part of the cycle, the second cycle, because why? Because you can see the first value from 1 to 2. It is actually, there's a different of signal there, right? So that's why I plot that first, and then I proceed plotting the next plot. Okay, so for this third cycle, we have 1 signal going up, 1 signal going down. So basically the 2 signals are in the same, I can say, in the same value, because both going up in 20 decibel, which another one going down in 20 decibel, which means they cancel out each other. So we are left with 1 signal, straight signal, with another one going down in the value, or we can say in the range of 20. So that is what left. So from there, the value, we will just plot the remaining signal going down, and then yes, we will see the, now we will go to the fourth cycle. So the fourth cycle is actually basically the signal is the same with the third cycle. What we have in the third cycle signal is actually the same with the fourth cycle, because we don't really have another addition of cycle there. So the final signal will look like this. Okay, so yeah, now we are done with the magnitude plot. Next we will go to the phase plot. Alright, so for the phase plot, just to remind all of you that the value of the vertical line is not decibel anymore, but then we have it in phase. So again, before we do the labeling of our semi-log paper, it is better for us to study the value first. So yes, we only have small value, which means we don't really have to adjust the semi-log paper value much. We can just use a standard value, which I can say the minimum value can start with 0.1, and it's 10 factor of 0.1, which is will go into 1, 20, 10, 100,000, 10,000, and so on. While the vertical, we can do the labeling from 0, 45, I mean the increment of 45 degree. So basically, for the phase plotting, it is similar. Well, I can say quite similar on how you are going to plot it according to the magnitude. It's just that you have to know how the plot looks like for phase, and you just have to understand that. Okay, so I will just leave it to you here. I hope you do understand this part. Okay, you are actually done with the face plotting. Well, actually, I forgot to plot the total representation of the face. Okay, so you have to do that because I forgot to do it, but you have to do it. Okay, and I think that's all for today's example. We'll see you in my next video. Assalamualaikum.